So now we're going to do one more practice problem of how to add some vectors together using the component method. So what we're going to do here, we have a similar question to what we did in tutorial with some different numbers. So we're going to redo this question. So it says tension 1, T1 is 14 newtons. So I'm just going to write 14 newtons on here. T2 is 20 newtons. And T3 is 25 newtons. So the question asks for the magnitude and the direction of the net force, or the resultant, acting on the object. And this is the object here, the dot that's right in the center. Okay, so if you couldn't see it, it was just a dot right there. So what we want to do is find the x and the y components of each of these forces, those three tension forces. So I'm going to make a table here with an x and a y. And on this side, I'm going to write T1, T2, and T3. So I have T1, T2, and T3. And the question asks me to find the net force. So net force means the total or the sum. So that means they want me to add those three forces that I got. So I'm just going to write T net for net tension or net force. And that's the same as doing T1 plus T2 plus T3. Okay, so before I begin, I'm just going to decide which way I want positive to be. And in this course, the convention is that positive is acting to the right. So I'm going to just write that. Positive is going to the right for x. Remember, the x-axis is the horizontal axis that's going left and right. And for the y direction, positive would be up. Okay, that means that negative would be going to the left for the x-axis, and a negative y direction would be pointing down. All right, so next what we want to do is find the x and y components of each of these three forces. So let's start with T1. So I'm going to take my T1 vector and I'm going to turn it into a triangle. Now when we look at T1, we can see that it's pointing to the left and upwards. So that means my x component vector, this one here, should be pointing to the left, and my y component vector should be pointing upwards. So I can label these as T1x and T1y. Okay, so that just means tension 1 in the x direction and in the y direction. And now you'll notice that since x and y are perpendicular to each other, I can put a little 90-degree symbol here, just that little box in the corner. Okay, so now what we're going to do is we're going to use Sohcahtoa to find T1x and T1y. So we'll start with T1x. First, we're going to label our three sides. So our angle we know is over here, 29.7 degrees. That means that the opposite side to that angle, T1y, would be called opposite. Also, we know that our 90-degree angle is right here. So we can think of this like it's an arrow, and that arrow always points to the hypotenuse. The hypotenuse is always the longest side of our triangle. And the third side, the side that's also next to the 29.7 degree angle, but is not the hypotenuse, that's called the adjacent side. So adjacent means next to. So it's the side that's next to the angle that we know, but not the hypotenuse. All right, so now if we're looking for T1x and we know the hypotenuse, we're going to write down Sohcahtoa. So T1x is the adjacent side, and 14 newtons is the hypotenuse side. So we're looking for the one that has adjacent and hypotenuse in it. So adjacent, hypotenuse, so that would be cos. So now I'm going to write down the ratio, so we would say cos of our angle, so our angle is 29.7 degrees, is equal to the adjacent side. The adjacent side is T1x over the hypotenuse, which is 14. Okay, so now we're going to solve for T1x. Because T1x is being divided by 14, the opposite of dividing is multiplying, so we're going to multiply both sides by 14. So the 14 will disappear on the right. So we end up getting 14 cos 29.7 degrees equals T1x. Okay, so now we know that the x component of T1 is 14 cos 29.7. But wait, we need to stop for a second and decide, should that be a positive or a negative? So we wrote down that that vector over there, the T1x, Do you see how we wrote that it's pointing to the left? Well, since it's pointing to the left and we said to the right is positive, that means the left must be negative. So I'm going to put a little negative sign in front of that. Okay, so now I'm going to do the same thing to find the opposite side, T1y. So T1y is the opposite side of the 29.7 degree angle. And again, we know the hypotenuse is 14 newtons. So now we're looking at Sohcahtoa to figure out which one we should use for opposite and hypotenuse. So let's see, we have opposite here and hypotenuse. So that means we should be using sine. So I'm going to write that one out. So we have sine of our angle, 29.7 degrees, is equal to the opposite side, which is T1y, over the hypotenuse, 14. Okay, again, we want to solve for T1y. So then that means we're going to multiply both sides by 14, and we get 14 times sine 29.7 degrees is equal to T1y. All right, so I'm going to put that in for my T1 in my y direction. I get 14 sine 29.7. Now don't forget again that we need to check to see if this is positive or negative. So we go back to our vector. That was this one over here, and remember it was pointing upwards. So since it's pointing upwards and we said up is positive, that means we're going to leave our answer as a positive value. So we don't put a negative in front of it. Okay, so let's stop and think about this before we move on to T2. So if you are looking for the adjacent side, you're going to be using cos because cos has the adjacent in it. And if you're going to look for the opposite side, you're going to be using sine. So every time we do this, we're either going to be writing hypotenuse cos angle or hypotenuse sine angle. Now I use this symbol here, theta. Theta is the symbol I'm using for the angle. Okay, and the angle that I'm referring to is the angle that's given to you in your triangle. Okay, so the 29.7 degrees in this case. So when we're looking at T1 and we're finding the x and the y components of it, we're either going to be doing 14 cos of the angle, 29.7, or 14 sine of the angle, 29.7. So all that we really need to do is decide which of these is the x component and which one is the y component. Well, all that we need to think about is, are we looking for the adjacent or the opposite side? So remember, cos gives us the adjacent side, and sine gives us the opposite side. So for the first T1 vector that we just looked at, when we were looking for T1x, that was the adjacent side. So since it was the adjacent side, we used 14 cos 29.7. And when we were looking for T1y, well, that was the opposite side. And since we were looking for the opposite side, we use sine, 14 sine 29.7. Okay, so just based on Sohcahtoa, if we're looking for adjacent side over here, we're going to use cos. If we're going to look for the opposite side over here, we're going to use sine. All right, then make sure before we move on that we need to look to see if something is positive or negative. So the x component's positive, again, if it's going to the right, negative if it's going to the left. The y component's positive if it's pointing up, negative if it's pointing down. Okay, so let's do this again with T2, but this time we're going to do it the faster way. So we're going to say it's the hypotenuse cos of the angle, hypotenuse sine of the angle. And all we need to do is decide which of those is the x component and which is the y component. So when we look at our T2 vector, if we're going to break this down into components, we have the x component pointing to the right because T2 is pointing to the right. And we have a y component pointing up because also T2 is pointing to the right, pointing up as well. Okay, so when we're looking for T2x, so that would be this T2, the x component of it, we can look at our angle here, 49.3 degrees, and notice that that side, T2x, is adjacent to that angle. So because T2x is adjacent to it, we're going to be using cos. Okay, remember we said adjacent over here, we use cos from Ka. So now we're going to just write right away, it's going to be the hypotenuse 20 cos of the angle, 49.3. And all we need to do now is stop to check whether or not this is positive or negative. Well, the x component is pointing to the right, so it's positive. We can leave it as it is. And then when we look for the y component, that would be this side over here, T2y. Okay, notice T2y is opposite of the 49.3 degrees. Since it's opposite, we're going to use sine. Okay, so now since we're using sine, we're going to say 20, the hypotenuse, sine of the angle, 49.3. Now T2y is pointing upwards, so we're going to keep that as a positive value. Okay, now we're going to take a look at T3. So T3 is not on an angle at all. It's pointing straight down. Since it's pointing straight down, it doesn't have an x component at all. So that x component will just be 0. And the y component is the 25 newtons. So I'm just going to write 25. But again, since it's pointing down, we need to remember to put a negative sign in front. Okay, so I'm going to erase all of this, and then now I'm going to pull out my calculator and I'm going to start adding everything up. So when I find the T net, or the total tension in the x direction, okay, so that's my value that I'm going to put in right here, what I'm doing is I'm adding up all of the tensions I got in the x direction above. So on my calculator, I'm going to type this up, negative 14 cos of 29.7 plus 20 cos 49.3, and then I don't need to add the 0 because if I did, it wouldn't change anything. Then I hit equals and I get 0.8811. Now I'm going to do the same thing with the y direction numbers. So I have 14 sine 29.7 plus 20 sine 49.3 minus 25. Okay, that's the same as saying plus negative 25. All right, now when I hit equals, I get negative 2.900. I have 8, 9. That 8 is going to get rounded up to a 9. All right, so now I know my net tension in my x and my y direction. But the question wants to know the magnitude of this. So when I'm looking for magnitude, I'm going to put these lines to the side, which show that I'm just finding a magnitude. And the magnitude is always going to be the hypotenuse of the x and y components. So let's draw a picture of this on the side. My x component is positive, so that means that that vector is going to the right, and it's 0.8811 newtons long. My y component is negative, which means that that vector is pointing downwards, and that vector is 2.9009. Now you can put the negative there or not, it doesn't really matter, but I'm just showing that the vector is pointing downwards, and that's because it's a negative. So now my magnitude, or my net tension, would be this vector here, which would be pointing in this direction. Okay, so I'm going to call this T net. I'm putting the lines on the side to show that I'm only finding the magnitude of it. Okay, so now what I learned earlier on was that this is a Pythagorean theorem question. I know that my x and my y components are perpendicular to each other, so there's a 90-degree angle right there. So then the side that's opposite of that 90-degree angle is my hypotenuse. And the hypotenuse in Pythagorean theorem is called C. The other two sides can be called A and B. It doesn't matter which one's which, as long as my hypotenuse is the C. So I'm going to use this to figure out what C is. So I'm going to write my Pythagorean theorem, a squared plus b squared equals c squared. And then I'm going to solve for c. So if I want to solve for c right now, that means I'm going to just have to take the square root of the other side. So when I take the square root of c squared, I just get c. So I need to take the square root of everything. So if I use that to find my net tension, what I'm doing is I'm finding the square root of the a squared, 0.8811 squared, plus the b squared, 2.9009 squared. So now I'm just going to type this into my calculator. So I'm typing square root of 0.8811 squared plus 2.9009 squared equals 3.03. Okay, I'm going to round to the nearest hundredth or 2 decimal places, so I'm going to stop there. And because my units for tension all along were newtons, I'm just going to put in newtons here. Okay, if you're not getting this answer, it's likely because your calculator requires that you put in a bracket. So what you would type on your calculator is the square root and then a bracket, then enter in all your numbers and then close the bracket. And then you should be getting it correct. Okay, so that's the magnitude. Next, we want to find the direction. So if we look at the drawing that we did on the side here, we're looking at this vector here. This is the net tension. We want to find the direction of that. So the direction of that would be given by the angle here. So this angle we can call whatever letter we want. We can call it x. Okay, let's call it x right now. So we're going to find that angle x. So we're going to think back to Sohcahtoa. I'll write that down again here. Sohcahtoa. So again, here we're looking for our angle x. We have this side over here, which is the opposite. And we have this side over here, which is the adjacent. Okay, so when we know the opposite and the adjacent, and we're looking for the angle, which one will we use? Sohcahtoa. Opposite, adjacent, so we're going to use tan toa. So let's write that out. So we would say tan of our angle, which we don't know, we're looking for this value, tan of x is equal to the opposite side over the adjacent side. Okay, so now we're trying to solve for x. So when we're trying to solve for x here, we're looking for an angle. We want to use the inverse button on our calculator. So x is going to equal tan inverse of that fraction that we have written. 2.9009 divided by 0.8811. Okay, so now I'm going to type this into my calculator. I'm typing tan inverse. Sometimes that means you need to hit second function. It depends on your calculator. So tan inverse of 2.9009 divided by 0.8811. And I get that x is equal to 73.1 degrees. Okay, so now if I'm looking for my net tension, this time I'm going to write it without those lines on the side, and I'm going to put an arrow on top. So the arrow is telling me that this is a vector because it has a magnitude and a direction. It equals 3.03 newtons, and in brackets I'm going to write the direction. And the direction would be 73.1 degrees below the positive x-axis. Okay, so let's take a look at it again. This is the positive x-axis over here. That's the positive x-axis, and our vector is 73.1 degrees. So this x value we got was 73.1 degrees, and it's below the x-axis. All right, so I hope that helps. Keep on practicing, and see you next time. Thank you.